Welcome to the second episode of our Every Node in Geometry Nodes series. This episode will be rather long, so I won't be talking too much, and let's get fast into Blender. For this series, we will be using the newest Blender 3.5. You can download it via the blender.org website or via the Blender Launcher, which is a utility software that you can download. Just search it in Google. And with this, you can download the newest Blender versions and experimental versions. As said, we will be using the Blender 3.5 version alpha, and we will be clicking Sprite Fried away. And here we can delete everything. And we want to have our cube back, of course, as always. And now let's open up our beautiful Geometry Nodes editor. And we want to create a new node tree. In the last episode, we looked at the geometry nodes. Funny, we looked at the geometry nodes in Geometry Nodes. All those nodes, you can watch them if you haven't watched the episode before. And today we want to look at the mesh nodes. First of all, adding nodes with Shift and A. So, and we will be starting right now. So the first node is the dual mesh node. And if you use this node, it seems quite confusing, but just what it does, it takes every face and puts for every face a vertex. So a vertex here, and a vertex here, and a vertex here. So just for every face. And then what it does, it connects all of those vertices and creates a new mesh. And what do we got? Exactly this. So with this node, you can also create really cool effects. For instance, if you take with Shift A into the add menu, if you take a mesh primitive, an icosphere. So if we look at our icosphere, first of all, I will erase my annotations. We can see that we have here, so for every face, I will draw our things here like this, and we can see that we get those kind of shapes, and with this we can make really cool shield effects. So if we take the dual mesh, you can see that we get really cool effects, and of course you can subdivide it and you can create shields with that. So let's move on to the next node, but maybe we'll erase my stuff here, which is the edge paths to curves node. So of course I can't show you this node on its own. We have to use a couple of more nodes to show you what this node does. But basically this node converts our edge paths, that converts it to a curve then. But to show you what it does, we need another node, which is also in the mesh submenu. It is the shortest path node. You can find it here. And we can plug the next vertex index in the next vertex index. So for a better example, let's delete this and let's take a plane and subdivide it a bunch of times, maybe 5 times, but simple. And here in Geometry Nodes, we want to use our edge paths to curves node, and we want to also use the shortest edge path node. And let's plug the next vertex index into the next vertex index. Now this node calculates the shortest path from every vertex through the edges of our mesh to our set end vertex. So we have to define an end vertex. How can we do this? We can just, maybe if we want to have this as end vertex, we can select that and we can go into the vertex group and create a new one and click on assign. Now we have to import this vertex group into Geometry Nodes. So let's grab our noodle here from the group input because we want to input our vertex group, and let's plug it into the end vertex. Now in our modifier properties, we want to use the end vertex and we want to use an attribute for this. And let's grab our group attribute. Now Geometry Nodes finds from every vertex the shortest path to this vertex. But what if we not want to have all vertices calculated to this vertex? We want to have one vertex. So let's grab another vertex, maybe here, and let's create another vertex group, and let's assign this, and we want to have this as the start vertice. So let's grab that, and we want to have the other vertex group. Now Geometry Nodes finds the shortest path from this vertice to this vertice. But this node, as default, takes every edge as the same cost. We can define different costs for different edges. So we can grab a random value node, and we can give every edge a random cost value. So Geometry Nodes goes from our start vertice, it calculates the shortest path to this, and then it looks what is the most cost efficient way to get to this vertex. And we can give every single edge another cost value, so it finds the easiest way to our vertex. So if we plug a random cost value in here, you can see it finds its way around to here. If we look at our cost values, they look like this. And we can of course change the seed. So you can see always Geometry Nodes tries to get to this point in the cost efficient way, and we can define the cost for every single vertice. Of course, we can also use a noise texture for this, for the edge cost. And here we can also change the scale. But normally for the edge cost, we use the edge length, because the longer the edge, the more cost it should have. So it should be more unlikely that Geometry Nodes finds its way through the longer edges. And we can calculate the longer edges in the mesh submenu if we use the edge vertices and we use a vector math node set to length. We can, set to distance. We can use the position 1 and position 2, and we can calculate the distance for every edge from the first vertice to the second vertice, so just the length of every edge, and we can plug that into the cost. So edges that are shorter have more weight than edges that are longer. So in edit mode, we have also, if you press down Control and left click, you can also find the shortest path. And if we now take our first vertice and we will take our second vertice and press Control and left click, we can see it's exactly the same path. So everything we did is right. So of course you can do way more with this node. This was just a very, very short explanation, but of course we want to get to more nodes, so I can show you more. So basically this node finds the shortest path in your mesh, and then it passes you the vertex index to this node, and this node then converts it to a curve. So we can also then use the next node, which is the edge path to selection node, and with this you can create a selection for every vertex that is used here. So if you grab a geometry delete node, delete geometry, and you use this selection on our plane here, and of course also the start vertice, you can delete the edge that gets used. So this is the selection for our edge paths. Moving on with all the other nodes, we have here also the Extrude Mesh node. And this node should be very familiar to most of you, because we know what extrusion is. We can extrude our mesh here. This takes all of our vertices, all of our faces, and extrudes them Most of you know this from edit mode. So if you take, for instance, all those faces and you press I, then you can also extrude those. And it's the same as in edit mode. So if we take all those faces and we use them in our first vertex group, we can use it also here for the selection. And then you can see we have extruded those in geometry nodes. But of course, we can also define a random value for the offset scale, and then you can get very crazy with this effect. You can also define only edges or only faces or vertices. Do whatever you want with it. But this node also outputs you the top and the side. So if you take the Extrude Mesh node again, it looks very strange, but you can say extrude only from the top. And now it extrudes from our top or only from the side. This is what those Booleans are for. Enough about this. Let's move on to our next node, which is the flip faces node, and this is very simple. Our faces have always two sides. You can see them in edit mode. Here you can turn on face orientation. Then you can see the outside face side and the inside side. It's very strange, but if you now take your flip faces node, you can flip them around if you need it in some corner cases. And of course you can also define a mask for the selection. And this node is very simple. So the next node is the mesh Boolean. This is also a simple and cool node. You can use this to cut holes in your mesh with another object. So let's take a cylinder. Let's change it as display type as wire so we can look through it. And we now want to have everything that is in the volume of those cylinder. We want to have it cut out. So we want to have a hole in our mesh. And we can do this with the mesh Boolean. So, but for that, we want to have the cylinder in our geometry node tree. So we can, via drag and drop, we can drag this into our geometry node tree. But of course we want to have it relative and as mesh 2. And now you can see we are cutting a hole in our mesh. And there are also other modes as difference and intersect. So it's the opposite of difference. So difference, you cut a hole out of the plane with the volume of our cylinder. And in intersect, we are cutting everything outside of the volume of our cylinder. Then we have the union, and this just unites our two objects together. Enough about this node, and let's move on with the next node, which is the mesh to curves node. And this one is very cool and simple. So we have here, let's delete our cylinder. We have here our grid, and this node takes every edge and converts it to a curve. With the curve we can then make really cool animations, like trim our curve like this. Let's enable the viewer. So we can make animations like this and maybe make it to 0.5. And after this we can convert our curve to a mesh again. So we can plug in a curve primitive, a curve circle, resolution down. And let's take also our radius down, and we can then join those two together. Join geometry with our original plane, and then we have those cool patterns here. Maybe take the radius a bit up like this so you can better see it. I'll make cavity on like this. and you can create really cool effects with that. But as said, really simple node. It just takes your mesh and converts every edge to a curve. Another node is the mesh to points node. It's even simpler one. So let's use it on an icosphere, because an icosphere is simpler. New geometry node tree. And let's use our mesh to points node. And now geometry nodes looks at every face, and it draws for every face a point. It's nothing more than this. For every face a point, and it looks like this. Now, of course, we don't have set it to a face. Of course, it also takes our vertices here. But if we set it to face, here you can see it matches my annotations. And we can also set it to edge. So for every edge, it sets a vertex, a point, and for every corner, and so on and so forth. And you can change the radius and so on. It's a really simple node. And we will move on to the next, which is the mesh to volume node. And this takes your original mesh and fills the volume. And then you can make cool things with the volume. So you can remesh your model with a volume to mesh node, for example. And you can always higher up the voxel amount. And this way you can remesh your model. The next node is the sample nearest surface. And this is similar as the geometry proximity node. So we have here two UV spheres, and you can see them. We have two UV spheres, and we take the second UV sphere and set as relative. And we want to sample something from this UV sphere. Set this to vector, because we want to sample the position of our UV sphere, of our second UV sphere. Now this node samples the position from this UV sphere from the nearest faces. So if we grab the set position node, we can use this position as something new. And if we now hide our second UV sphere, we can see it uses the nearest faces as the position. And you could use it to sample any kind of attribute that you have on your second UV sphere. For instance, the normal or custom set attributes, maybe as offset. That could be strange. Yes, like this. But you can see it adds the normal to our mesh. So it works. As said, you can pull every kind of attribute that you have here on your second icosphere. So let's move on with our next node, which is the sample UV surface node. For the next node, we take a grid like this, and we will make proportional editing on, and we create something like this. We take another plane, take it on the top, and now we want to have the same displacement as here on the bottom on this plane. For this, we can use the other node, which is the sample UV surface. To have now the same position as this on the bottom, we take the bottom plane, set it to original or relative. It's unrelevant in our case. And we will set this to vector. We want to pull the position of the bottom object, which is the value, and the bottom object has the UV map. We will call it 2, UV map 2. So we want to pull with a named attribute node, set to vector. We want to pull our UV map 2. UV map 2. our sample UV is our current UV map, which is our normal UV map 1. Now we have our position, and we take a set position node and set this as our position. Of course, we have to subdivide it, and now this works. If you set it to original, you can see, and you can of course also change something here, and it will also change on the top. Let's move on with the next node, which is the scale elements node. And let's delete everything, and we want to use a icosphere. And here we can create a cool effect. For instance, we can take our cool dual mesh node and we can create a little shield. And we can split our edges so they're not connected anymore. And then we can take our scale elements node, scale elements, and without this, you can see we can just scale our whole object or just a single axis. But if we split our edges, we can scale every single face. And with this, we can create cool effects, like if we grab a noise texture and into the scale, we can make really cool effects like this. And you can play with the scale. And then you have a cool shield effect like this. So this node scales your object or the faces or the edges, whatever you want. Next node is the split edges node. So we had it currently, so this node splits all of your edges. So if you have a face here, you can see it's connected with all the other faces. If you say split, you can see it's not connected anymore. So this is what this node does. And you can of course also define a selection. So for what part you want to have this node. Very simple node. So the next two nodes is, I think most of you know those nodes. So subdivide mesh just subdivides your icosphere. So if you go into edit mode, click on subdivide, this is what it does. It doesn't change the shape of your object, but it does give you more topology. Of course, you can higher it up. And below that we have the subdivision surface. This will smooth your object. And you can see here we have split this face. So it looks different here. And you can see this smooths your object. And we have split this edge here, so it looks weird, but let's look from here. And you have here also this edge crease. So how much it should smooth your mesh. Also vertex crease. And you can control this with a field. Very simple. I think you know this. It's as the modifier exactly the same node, maybe with more properties. Next node is the Triangulate node, and this node is also very, very simple. If you use it, you can see a difference, but this is because this node takes your current faces, and if they have 4 edges, it will split your faces into 2 triangles. So it converts every face to a triangle, no matter what face it is. So if we apply our geometry nodes modifier, you can see we have a lot of triangles. Now let's move on with this category, and those are mainly output nodes, so you can grab information about your mesh. So at first we have the edge angle node, and this gives you a value for every single edge, how sharp the angle is there. So if we look from the viewer, you can see those faces here have a higher edge angle as those faces here. And if you grab a color ramp, you can see it here. If we subdivide our mesh, you can see it even more. It is like the geometry. It gives every single edge a value of the angle that it has. You can use this, for instance, if you want to have something like dirt. And the next node is the edge neighbors node. So this node outputs us the number of faces that use those edges. So if we go in here and we delete one face, we have now here 3 edges that are only used by one face. So if we use a compare and we want to compare it as this, and we want to set it to equal. So if the edge neighbors is equal to 1, like this outputs us a value of 1. If we now take a mesh to curve node, mesh to curve, we want to have this only converted as a curve if the edge neighbors is equal than 1. Now we only have those edges that are only used by one face. And we can join this together, join geometry like this, and we can convert our curve to a mesh. And as a profile curve, we take a circle. And now we have something like this. And every time we delete now a face, maybe also this one, we have this kind of cool pattern. This is an example you can use this node for, but let's move on. The next is the edge vertices node, and we've already used this. So this node outputs us the 2 vertices that one edge has. So every edge has 2 vertices. That makes sense, right? And it outputs us the indices for the first vertice and the second, and also the position of the first and of the second. So as already shown, if you take a vector math set to distance, you can get the length of every single edge, because this calculates you the distance between the first vertice and the second vertice. And those are connected with an edge, so you can get exactly the edge length of your edges. The next node is the face area node, and this is a very simple node because it outputs you the face area every single face has. So if we will look at it, you can see those faces are a little bit bigger than those because it's brighter, and you can get the total amount of the total face area of your whole object if you take an attribute statistics. Where is it? Attribute statistic node. And you use the face area as attribute and your object as geometry. And we will take the sum. And now we have, if we go into the spreadsheet, we have the total, if we will switch this to viewer node, we have the total amount of 6.1 Blender units. So this, of course, always uses Blender units and not centimeters and not miles. This uses Blender units. The next node is the face neighbors node. So this node outputs us the number of edges our face has, so the number of sides. And here is the number of faces that are connected to our face. After this node, we have the face set boundaries. So here I made a little something. So I have subdivided our UV sphere a bunch of times so we can see what's going on. And here I have taken a Voronoi texture and I've used the color, and then the face set boundaries outputs us the boundaries of our face sets here, as you can see here. And then you can use this as, for instance, the UV seams of the UV map, as shown here. This is a very useful node for the UV unwrapping. So you can create here, for instance, with the Voronoi texture face sets, and then you can calculate the boundaries of those face sets with this node, and then you can use this as seams in the UV unwrapping. After this node, we have the isFacePlanar node. This node outputs us simply if a face has the same normal than another face. The next node is the isShadeSmooth node, and this node just gives us a Boolean of if a face is shaded smooth. So if we select a face here and we shade it smooth, then we have those data into geometry nodes now, as you can see here. A very, very simple node. And the next thing is the Mesh Island node, and this gives us the indice of our individual island. So an island is a part that is not connected to another part. So if we duplicate our thing here, you can see this is another island because it is not connected to the first island. And then we got another index for this island, and we have also the island count. So this is first and second. And yes, if we have more islands, then of course this gets updated. We have already used the shortest edge paths, so we will be moving on with the vertex neighbors. So this node simply gives us the number of vertices that are connected to our vertex via a mesh. This is equal to the number of connected edges, and below we have the face count. So here we have an integer for how much faces contain our vertex, and this was nearly the last node. The last node is the set position node, set shade smooth node, sorry. And this is a very cool and simple node because you can set parts of your mesh or your whole mesh as shade smooth. As in the viewport here, you can use this, and then you can toggle if something should be shaded smooth. And you can also use a random value node or another mask. Of course, you can also use something else with a Boolean and into shaded smooth, and you can randomly shade your faces smooth, or you can use another mask or another input here, for instance a vertex group. And yes, this were all the nodes in the mesh submenu. I hope you liked this little tutorial, and if you want to support me or you want to have great and cool materials that you can drag and drop into your scene, I have a material pack on my Gumroad page. You can click the link in the description. There's also a free version of it, so don't miss it and try it out. And yes, you can give me recommendations for other submenus, and other than that, I hope you liked it, and hopefully see you next time. Bye.